Hello my dear students. In this video I'm going to talk about graphical representation of solution of system of linear equations. The general form of linear equation is written as a1 x1 plus a2 x2 plus up to the term an xn is equals to b, where a1, a2 up to an and b are called coefficients, and they can be any real or complex numbers, whereas x1, x2 up to xn, these are known as variables, unknown variables. Note that the graphical representation of any linear equation represents a straight line. For the simplicity, let's consider the linear equation in two variables. Let's consider x1 minus 2x2 is equals to minus 1. This is a linear equation in two variables x1 and x2, where the coefficient of x1 is 1 and coefficient of x2 is minus 2, and the constant number on the right hand side is minus 1. As I just now mentioned that the linear equation represents a straight line, hence this linear equation in two variables represents a straight line in Cartesian coordinate system of two dimensions, where x1 is the distance along the horizontal axis and x2 is the distance along the vertical axis. If we consider this two-dimensional Cartesian coordinate system, then in order to obtain the straight line corresponding to this linear equation, we need at least 2 points on that straight line. If I assume that this equation x1 minus 2x2 is equals to minus 1 is represented by line L1, then in order to get at least 2 points, let's assume that x1 is equals to 0. Then the value of x2 will be equals to 0.5. And if I assume x2 is equals to 0, then the value of x1 is equals to minus 1. Hence, one of the points on this straight line should be 0, 0.5, and other point is minus 1, 0. This point 0, 0.5 is this point. If we assume that this is the point 1, this is point 2, this is point 3, similarly this is point 1, this is point 2, this is point 3, then this point is considered as 0, 0.5, and the second point minus 1, 0 is this point. So in order to get the straight line corresponding to this linear equation, what we have to do, we have to join these two points together. Let's join them together. Let's join them together and then extend the line on both sides. That would be our straight line corresponding to the equation x1 minus 2x2 is equals to minus 1. So we'll represent this as the line L1. Now one more thing which I want to mention here is that this point 0, 0.5 satisfies this equation. It means that when you substitute x1 is equals to 0 and x2 is equals to 0.5, x1 minus 2x2 is evaluated as on minus 1, which is the right hand side. It means that this point satisfies given linear equation. Hence we call this order pair, the values of x1 is equals to 0, x2 is equals to 0.5, as the solution of this linear equation. Similarly, minus x1 is equals to minus 1 and x2 is equals to 0 also satisfies this equation. Hence it is also called the solution of this linear equation. In general, we can say that all those points on this straight line are the solutions of the corresponding linear equation. We can say that there are infinite many solutions of this linear equation because there are infinite many points on this straight line. Now if we assume, if we take the system of linear equations, let's consider one more linear equation along with the considered equation. Let's consider another equation, say minus x1 plus 3x2 is equals to 3. Let us assume that this linear equation is represented by straight line L2. Then in order to get this straight line, we need at least 2 points on this straight line. So we will assume that x1 is equals to 0, then x2 is equals to, that would be 1, and for x2 is equals to 0, x1 would be equals to minus 3. Hence one of the point on this straight line is 0, 1, and another point on this straight line is minus 3, 0. Let's plot these 2 points on this Cartesian coordinate system of 2 dimensions. This should be 0, 1, so this should be this number, right, this point, and minus 3, 0, this should be this point. So let's join these 2 points together and extend it on both sides. So that should be okay. So this is the straight line joining the points. Assume that this is L2. Now these are the points on this straight line, hence they are known as the solution of this second linear equation, minus x1 plus 3x2 is equals to 3. And we can also notice that there are infinite many solutions of this linear equation because there are infinite many points on the line L2. One more thing you have to notice, that this point, which is basically the point 2, this is the point 3, 2, means the value of x1 is equals to 3 and value of x2 is equals to 2 is the point which is on the straight line L1 as well as on the straight line 2, and such point is known as the solution of system of linear equations. It means that the straight lines where they crosses each other, that point is known as the solution of the system of linear equations. That is basically the graphical representation of solution of system of linear equations with the unique solution. Hence we call this system, which has the equations x1 minus 2x2 is equals to minus 1 and minus x1 plus 3x2 is equals to 3, as the consistent system with a unique solution, because the corresponding straight lines to these linear equations crosses each other at a single point, and that crossing point, that intersection point, is basically the solution of the system of linear equations. Let's consider one more example. Let's consider 2 more equations. Let's say x1 minus 2x2 is equals to minus 1 minus x1 plus 2x2 is equals to 1. In the previous video we have discussed this example, and we said that these 2 linear equations are same equations because one can be obtained from other equation by multiplying with minus 1. So if we multiply the first equation with minus 1, we will get second equation. If you multiply second equation with minus 1, we will get the first equation. It means the solution of these 2 equations would be same. Okay, let's assume that this is the straight line L1 and this equation gives us the straight line L2. In order to get the straight line of this linear equation, we need at least 2 points on this straight line. Let us assume that x1 is equals to 0, then x2 would be equals to 0.5 and if we assume x2 is equals to 0, then x1 is equals to minus 1. It means that these 2 points are the points on the straight line L1 and L2. So let's join them together and extend them on both sides to get the required straight line. Okay, so we'll join them together and extend them on both sides. That would be our required straight line. Okay, since we know that these two linear equations are same equations, so the solution of these two linear equations would be same. Hence they give us the same straight line L1 and L2. The point on the line L1 would be same as the point on the line L2. Hence there are infinite many solutions because these lines are meeting each other at infinite many points. Hence this is a consistent system with multiple solutions, or this is a consistent system with infinite many solutions. Let's consider one more example. Okay, let's consider one more example of system of linear equations. Let's consider x1 minus 2x2 is equals to minus 1 and minus x1 plus 2x2 is equals to 3. Let us assume that the corresponding straight line to this linear equation is L1 and this linear equation represents the straight line L2. We already know that this straight line passes through 2 points 0 and 0.5. Another point is minus 1 comma 0. So this would be the points on the first straight line. Okay, let's join them together. Let's join them together and extend it on both sides to get the required straight line L1. And then in order to find the straight line of the linear equation minus x1 plus 2x2 is equals to 3, we need at least 2 points. So let's assume x1 is equals to 0, then x2 would be equals to 3 upon 2, which is basically 1.5. And if we assume x2 is equals to 0, then x1 would be equals to minus 3. Hence there are 2 points, one is 0, 1.5, another one is minus 3, 0. 0 comma 1.5 would be this point, if this one is 1, if this one is 2, and minus 3, 0 would be this point because this is 1, this is 2, and this one is 3. So that should be minus 3 here. So these are the 2 points on the straight line L2. Let's join them together and let's join them together and extend them on both sides. That would be the required straight line L2 corresponding to the second equation. Okay, this looks a little bit weird. This should be like this one. Okay, so we'll join them together and we can see that the straight line L2 and straight line L1, they are parallel with each other. So if we extend them infinitely on both sides, they will never cross each other. We know there are infinite many solutions of the equation x1 minus 2x2 is equals to minus 1, and there are infinite many solutions of minus x1 plus 2x2 is equals to 3, but there is no common solution. Hence we say that this system of linear equation does not have a solution, hence it is a inconsistent system. So graphically, according to the graphical representation of the solution of system of linear equations, if the straight lines of the given linear equations are crossing each other at a single point, then the system is consistent with a unique solution. If they are crossing each other, if they are meeting each other at multiple points, then we call it a consistent system with multiple solutions. And if the lines are not crossing each other at any point, then the system does not have a solution, hence it is called inconsistent system. If you have any question regarding this video, you may ask me in the comment section. I will try my best to resolve your queries. In the next video, I will be talking about procedure to find the solution of system of linear equations. Thank you.